hello to colleagues online. If we think about drones today, we immediately think about that they're everywhere. Got them, military and surveillance drones. You've got drones doing remote sensing and mapping. You've got drones delivering packages, and of course, you've got drones to take nice pictures and videos of your holiday destinations. So they're really everywhere. And as you've heard from Sail Drone, we're also taking to the seas with drones. And that's what I'm going to talk to you today, some innovations in remotely operated and autonomous surface vessels and how they can contribute to a digital twin. I'm with Fugro, and my name is Louis Demargne. So one of the challenges of the UN Ocean Decade is to develop a comprehensive digital representation of the ocean. This idea of the digital twin that Uta was talking about yesterday. And the UN Ocean Decade declared last week at the One Ocean Conference in Brest in France that they wanted to achieve 80% of the seabed being mapped by 2030. That's what they want to facilitate and achieve. But we're quite far away from that. As you all know, there's about 20% of the seabed that's been mapped through direct observation. In terms of in situ observations, most of those are at the sea surface or right below sea level. So we've got a long way to go. You can see here in the bottom right, this is a map of Australia and known bathymetric data. It's very sparse. In fact, this yellow bit here, this one, is actually the result from the search for the Malaysian Airlines MH370. That was about 10,000 square kilometers of data. It took 3 vessels, 5 weeks to collect all of that data and months of data processing. And with remote and autonomous systems, we can accelerate that. So this is the way we capture that type of data today. It's these big vessels. This one is about 83 meters long. It's got 60 people on board. We've got multi-beam echo sounders, towfish, you name it. And one of the things that we're doing at Fugro is as we transition to net zero carbon emissions by 2035, that's our target, we want to move away from that. And what we've developed are these USVs, uncrewed surface vessels, because we figured that anything that just needs manual handling can actually be automated. And so we're trying to automate all of the processes that are on these previous vessels onto these systems. And you can see we have a much smaller crew here, about 10 people who can operate the system 24/7 with shifts and so on. So it's really changing the way we work. So what are the core components of this system? The first one is indeed the USV itself, the uncrewed surface vessel. And it's got a bunch of sensors on board, multi-beam echo sounders, but also sensors and software for collision avoidance, for obstacle avoidance, of course, because it's out there. The other thing we can do is we've got a number of USVs that also carry remotely operated vehicles. So these are tethered systems that we can pilot from remotely, and we can go and inspect all sorts of things with that. Now, the real game changer is this two-way satellite data connection. This is where we use that high bandwidth connection to not just make sure that the uncrewed vessel is doing what it's supposed to do, but also to pilot the ROV, for example, or just to correct directions, or just to control the whole vessel. This is absolutely key. And we have about 6 remote operations centers currently operating throughout the world. The other key aspect of that is also that we can then, in real time, transmit the data into the cloud, get it processed within a number of days rather than weeks or months. So those are the core components of the whole system. And there we can produce and deliver data products to the end users directly into their desktop. So what are the benefits? Why did we care about this? Well, there's 3 that we can talk about. The first one is safety. We have to take care of our people in Fugro, and the ocean environment can be a very hostile environment, as you all know. And by using these systems, we have people who are in the safety of a land-based office. It provides greater flexibility in terms of working hours, and also bringing in experts to look at data specifically with certain expertise in mind. It's also a lot more efficient in terms of data acquisition. I'll talk about that in a minute, but also in terms of data processing data in a matter of hours and days rather than weeks and months. And then last but not least, you can imagine that compared to the previous vessels, even though these are still diesel operated and we're moving towards electrically operated USVs, the carbon footprint is reduced by about 95%. So there's a sustainability advantage and benefit there, which also helps our clients who are also targeting net zero emissions. Those are some of the benefits. What do we use these systems for today? First of all, we use them to inspect all sorts of assets on the seafloor. We can look at, we recently completed a 100-kilometer pipeline inspection. That was a first for us off the coast of the Netherlands in the North Sea. We can look at underwater structures of offshore wind farms and other types of energy infrastructure out there. And the whole point of that is really to just replace what used to be done through manual labor in very dangerous and hostile conditions. But what we're really interested in here, particularly for the Ocean Decade and that goal of mapping the sea floor, is that it's really a force multiplier. We can actually deploy multiple USVs at the same time. They work in parallel, sweeping the sea floor. So very efficient data collection. Most of the time there will need to be a mothership also collecting data. So we're really multiplying that ability and that capacity to acquire data, all of that being sent to the cloud and processed as quickly as possible. And we're pushing that autonomy as fully as we possibly can. You can imagine if we have multiple of these systems, it then becomes, we have to look at maintenance and refueling issues. And this is where the Robodoc, this is something we're working on right now and developing. It allows the vessel to go in there, get maintained, refuel without the intervention of anyone. So pushing those limits of autonomy. So really, just a very quick breeze through some of the capabilities that exist today. There's a recognition by the UN Ocean Decade that innovation will be key to achieving some of the challenges and the goals of the Ocean Decade. And this type of innovation throughout the value chain can really help to achieve these goals. And it's real, it's happening now. We've completed multiple projects with the Australian Hydrographic Office, with NOAA, in North Atlantic and in various areas. And you've heard from Saildrone, and there are other companies as well working on this. And I truly believe that that's going to make a big difference to reaching those goals. That's it. If you want to learn more, of course, please go to fugro.com. And we've also got a LinkedIn channel and a YouTube channel with some really nice videos of some of those systems. Thank you very much.